So as we look at this, the U-try solution, we have division of radicals. One or two terms in the denominator have a radical. Okay, so again, if there's two terms with one or both of them having a radical, we need to multiply by the conjugate of that denominator to rationalize it. Okay, there is a process you'll learn in pre-calc rationalizing the numerator. It's the same thing but in reverse. So when we look at this, remember we do not add radicands, so this does not become 6 minus 5 under the radical. Okay, so the conjugate, keep the first term the same. Keep the second term the same. Change the sign. What I multiply the bottom by, I multiply the top by. Now also another thing to consider is be mindful of where the radicals stop. Don't inadvertently convert it to where it is all under one radical. Okay? Get in the habit of doing this. That will force you to remember that it's a distribution or a FOIL depending on number of terms in the numerator. Okay? So the top I have to FOIL, the bottom I can use FOIL box, whatever, I can use that difference of square shortcut. 2 times square root of 6 is 2 root 6. 2 times square root of 5 is 2 root 5. Remember, if it's outside the radical, it stays outside. Minus square root of 18, we've already seen that. We know how we can jump right to that. Minus square root of 15. Okay, so I know that blue, black. I know that this is going to become 3 root 2 from the last problem. Okay, when you look at that, none of those have the same index, or none of them have the same radicand. They all have the same index. We don't have any like radicals to combine. Okay, we may be able to do that, we may not be able to do that. It all depends on the values we're given. Okay, so that's in the numerator. I'm going to use the shortcut. This is my A, that's my B. So in the margin work, A squared minus B squared. Square root of 6, quantity squared, minus square root of 5, quantity squared. Power matches index, we take out the base, is 6. Power matches index, we take out the base, it's 5. I've started with similar numbers as my first example in the past, and what I've often seen students do is, well, they'll say this, when you multiply by these, they automatically become 1. That's not the case. So multiplication by the conjugates does not cancel it to 1 unless the numbers will get you there. Okay? So this would be over 1, so I really don't need to write that 1. Just please note, I am telling you that the multiplication of the conjugates does not necessarily mean it's going to become 1. Oftentimes what I see students do, they'll just multiply the top and they'll cross these out. That's not what happens. It depends on the numbers. So 6 minus, if they have something like this where it's 6 and 5, becomes 6 minus 5 down here using the shortcut, it could be 1. It could be 4 and 3, 7 and 6. If they subtract the 1, then the denominator would be 1. Okay, so the answer here is 2 root 6 plus 2 square root of 5 minus 3 square root of 2 minus square root of 15. Alright, and I just wrote it all over myself, in the next clip, we will be moving from 1.3 back into 2.6. 2.6 was labeled other equations. In there we'll have radical equations. The process that is in there, please note, the process that we do for radical equations does not get applied to what we just did here. Okay, we need to multiply by the conjugate for something here. The pathway we take in radical equations to solve those are for radical equations. These are radical expressions. So when they have the radical and the equal sign, we need a different path. Don't take that information and apply it back to this. Okay, so we'll do that in the next clip.